Did you pass them back? All right, question number 1. Which experiments are useful in demonstrating that air is matter, has mass or volume? So, group 4, which one shows that air has mass? Air has mass. Yeah, the only one that uses an electronic balance that shows air has mass would be station 1 up here. Good. Group 5, which experiment shows that air takes up space or has volume? Okay, and how does that show that air takes up space? I thought that showed that air has mass.
Oh, like, makes the bottle, like, more firm.
Okay, which, that would more so be explaining what? Something's pushing from the inside of the bottle. Yeah, so if you wanted to try to explain why the soda bottle was hard to squeeze, I'd say save that for question 2, pressure. Okay? I'm still looking for a volume. Air takes up space. Yeah, station 8 and 9. So we actually measured the volume of the air inside the syringe. Here we made the volume smaller, and what happened to the pressure pushing back on your thumb? So as the volume got smaller, Joey, what happened to the pressure? The pressure increased. Yeah, so that's a special relationship between pressure and volume. So station 8's kind of in between question 1 and 2. But yeah, I'd say it's both volume and pressure. You might want to label station 8 as Boyle's law. We'll talk about that later. That's one of the laws that we need to discuss. There's a mathematical relationship, but it's an inverse relationship. As volume got smaller, the pressure got bigger. What happened in station 9, group 6? What happened to the volume when we changed the temperature?
It also changed the volume of the air.
Right, so as the temperature got hotter, what happened to the volume?
The volume increased.
The volume increased. As the temperature got colder, the volume decreased. That's a mathematical relationship between volume and temperature. You might want to label that as Charles' law. That's one of the other math laws or scientific laws we'll talk about. So yeah, I would say those are the 2 main volume ones. You could probably also include number 2, that the water did not go up into the cup. Why? Because there was something already in the cup. The air was taking up space inside the cup, and therefore water didn't fill the cup. I remember doing that one as a little kid. I think my science teacher in 1st grade showed that. She put a little cotton swab in there, put the cup underwater, and as long as you don't tilt it or tip it, letting the air out, water doesn't go up into the cup, and it was kind of magical. Brought out the cup, and the cotton swab was dry. So that was kind of a cool one. All right, let's move on to pressure. Which experiments are useful in demonstrating that air has pressure? Number 7, Livy. Experiment 8. Yeah, so that's a pressure volume one that the air pushes back depending how you change the volume. What is another pressure station up here? Number 11, Alex. Number 3, yeah, why can't you blow up the balloon in the soda bottle? The air is pushing back on you, creating pressure. What kept the piece of plastic in place in number 4? Doesn't water want to just fall down? The pressure in the room, that air is pushing up. It's actually pushing everywhere, but there's more surface area underneath that's pushing up on that plastic, keeping that plastic in place. What kept the water inside the little bottle with the hole when the cap was on? What was pushing on that opening? The room, the air pressure. So the air pressure in the room was pushing on this tiny opening. As long as the cap is on, then the water doesn't flow out. What crushed the can? Pressure. The air pressure in the room was pushing on that. What kept the water up in this test tube here? What was pushing down on the tub of water? Air pressure. Pushing down on the water kept that water up in the test tube. You might want to label station 7 as a barometer. That's the meter that measures barometric pressure. Normally, we don't have the test tube filled with water. Anybody know what it's normally filled with? Yeah, mercury. Now we don't really have those hanging on the wall anymore, just because if that would crack, that would be a lot of mercury. That would be like hazmat cleanup. Any guesses, because water's less dense, how tall that test tube could be and still be filled with water? So the atmospheric pressure pushes down on the water, that keeps that water up in that test tube. Any guesses how tall that test tube could be? And still be filled with water?
5 feet.
5 feet? Taller.
15 feet.
Taller.
100 feet.
Not quite. I mean, you could fill it with 100 feet of water, but then because the outside air pressure isn't enough pushing down, the water will drop until it gets to about 33.8 feet. So that's a cool little fact you could write next to number 7. Atmospheric air pressure, normal pressure in the room at sea level, is about 33.8 feet of water. Does it make sense why we don't make barometers out of water? Yeah, we don't have 33 feet of wall space. The cool thing is, because mercury is a lot heavier, a lot more dense, you could fill a mercury barometer with 760, right about there, 760 millimeters of mercury. And because it's so heavy, the atmospheric air pressure is only able to push it up about that tall there. So it made a really nice instrument that used to hang on the wall, but now we have digital spring scales that can measure that pressure. Any questions? And station number 10 would also be a pressure example. If there's air in the straw, it's pushing on the water, not allowing the water to go up the straw. So we said 1 was mass, 2, 8, and 9 were volume. Basically everything is pressure. 8 was also pressure and volume. So yeah, a lot of those pressure stations. Question number 3, explain any differences between your predictions and actual outcomes. Group 7, what's something that you thought was going to happen that actually didn't happen? I know, it's kind of like magic, but yeah, there's a lot of air pressure in this room pushing on that plastic. Yeah, cool. Open it up to anybody else. Anybody surprised on anything?
I thought the balloon was going to blow up inside the bottom.
Yeah, it's not that hard to blow up a balloon. Was anybody able to blow it up? Nick, were you able to?
No.
Huh. Not a single soul was able to blow it up. You think I'd be able to blow it up? Played trumpet ever since 5th grade. Diaphragm muscles, track and cross country. Should I try it?
Sure.
Sweet. Ewa, can you just look at the phone numbers over there that if something happens, like you'll call?
Yeah.
Okay, sweet. Same bottle that you use is back here? Nothing special about it? No tricks, anything? Nope. Here goes nothing. Try to get this on the video camera over here. Hopefully I don't pass out. That should work. Alright, here goes nothing. Try that again. Did I get it?
Yeah.
You got that on video too. How do you think I did that? How do you think I did it? Don't try that at home.
You like kept the air in it, and you took the breath.
Right. Didn't you guys try to blow it up?
You like pinched it off so you could like keep the air in there.
Isn't that how you normally blow up a balloon? I'm confused. I don't get it. Not a single soul in here could blow up the balloon. That surprises me. How can an old man like me blow up that balloon? Tricks? Yeah, okay. What sort of tricks might I have done? No? You think there was a hole in it? Bella verified that it was not a trick bottle. It was the same bottle you used, guys, back there. Bella, did I pay you like before class to say that? No? Okay. How do you think I blew it up? What? What if I did it really easy?
What? What?
What?
Oh wait, didn't you do that alcohol squad with the balloon?
Yeah, I didn't want your germs on it. I saw that slobber on it yesterday. I wasn't touching it after that. Wait, it's that easy?
Well, you stretch out the balloon.
I stretched out the balloon?
Yeah, because you already blew up.
Yeah, that's how air
So
works.
I can get a new balloon. Would that make you feel happier?
Yes.
Yeah.
Yes.
All right. Does it have to be a pink one? Can I use a different color?
I prefer
Okay. Maybe it was a trick balloon.
Except you can block except it's so
Fresh balloon.
Maybe we
You
should
wanted
do it.
to. Oh,
Aha.
Yeah.
I guess I blew it too hard that it broke. All right. Never had that happen before. How did I blow up the balloon? You just don't have enough air strength to do that? Not enough pressure?
You like squeeze the bottle a little bit?
Yeah. All right. Kaylin, check out my bottle. See if there's anything you notice about it.
Don't hold it.
No? You?
Nice, bro. Nice. Nice stat.
You need to be a little bit more skeptical than that. Give it to Luke. You notice anything about that bottle?
Yeah, you squeezed it.
I
Okay.
noticed it. I'm not even there.
Like stuff in it.
This looks like water.
Okay.
There's literally.
Nobody's looking at the bottom of the bottle.
Oh, there's a hole.
Oh yeah.
There's
so
many holes.
that was really good.
But that Bella said there were no holes when I asked her to look at it. You think I switched out the bottle?
Yes.
I caught it. I said,
When
"There's
would
a
that
hole."
have happened?
Right there.
What's-
Oh, you did right in front of us.
Remember, I did it right in front of you.
Oh,
Didn't even take.
No, no, you turned over there. Yeah, when you dropped it.
Oh,
Yeah, yeah, when you
Remember
dropped
when
it.
it fell?
Yeah.
And then I went down to pick it up. There was another bottle down there. You would not want to try this at home. I had a student before I told them how I did the trick. He thought he wanted to be as cool as me. He went home and tried it all night long, and he basically broke all the blood vessels under his eye. He came back the next day looking like a raccoon. So now I tell you before you leave because yeah, I don't want anybody to break their blood vessels. That's why you got to be so careful. You can't even drink out of a straw after having your wisdom teeth out because that changes the pressure in your mouth, and you don't want to like blow a blood clot or something. So yeah, you can definitely do that with tiny little holes in the bottom of the bottle. All right, we'll keep that ready for next period. Don't tell sixth period. All right, it's all ready to go. Anything else surprising?
Wait, so why's your face turned red if it was holes in it?
It's all in the acting. It's all part of the process. It's like on the days teachers are smiling. Who knows whether they're actually happy inside? Oh, Nick, it's so nice to see you today. How are you doing? Yeah, great. Okay, no, just joking. I genuinely like my job. Anything else surprising? All right, well, let's take a look at question number 4. Real life experiences related to anything up here, mass or volume related. Open it up to anybody. Where have you seen this stuff in real life? I should probably edit that out of my video. Nick, I really do like seeing you every day.
Thank you.
Real life examples. Mass or volume. You put something in a bottle that weighs more. Bombergers uses this every day. They know how much to charge people. They put a certain gas, not in a soda bottle, but in a tank. Propane. If you're paying for a 20 pound propane tank fill, you go out there, they put your tank on the scale. If it weighs 20 pounds, they put 20 pounds of propane in. It better weigh 40 pounds at the end. So yeah, bottles with gases weigh more. Good. Open it up to anybody else. Real life examples. There's a spider that does number 2. It's called the fisherman spider. If you've never seen a fisherman spider, look it up on YouTube. They build a net, like a little web. They pull an air bubble underwater with them, and as they're fishing for fish, kind of attached to like a blade of grass, they don't want to go up and give away their hiding location, so they just stick their head up in the little cup or the little web, take a breath of air, and they keep fishing. So that's kind of cool. Have you ever had a hard time putting something into a container because there was already air inside? Like number 3. The janitors do this every day. If you've ever seen the custodial staff put a new trash bag into a trash can, sometimes they have to fight with it. So they oftentimes poke little holes in the bags. But what I did at home is I just drilled 2 tiny little holes, that, not quite at the bottom of the trash can, just say there's turkey grease in there, you don't want that leaking all over your floor, but maybe about an inch up from your trash can. That way when you go to put a bag in, the air exits just like the soda bottle did, and you can put that bag in as easy as that. But without those little holes, you can really have a hard time putting trash bags in trash cans. Anybody ever try to drink out of an igloo and you know it was full, but you couldn't get anything out of it? It's kind of like a bottle that has a hole in the side of it. What do you have to do to get the liquid to come out? Yeah, you gotta unscrew the top. You gotta let air in so that you don't have a low pressure vacuum system in here. Anybody use laundry detergent kind of like these? Push a little button, liquid laundry detergent comes out. Have you ever had a hard time getting detergent out? So how do you get the detergent out? Yeah, there's a little screw cap on top. Why? Because it's science. It's gas laws. It's gas pressure. So you got to open up that top to let air in. That way the air pressure is balanced, and then you can push that for a few more loads of laundry before you have to open that cap again. Any other real life examples? We talked about how number 7 was a barometer, except we don't use water barometers. We use mercury barometers. Where have you seen hot gases expand before? Usually a good time of year to see this sort of thing. Fireworks, yeah, that's more July. Hot gases take up more space. Yeah, hot air balloons. Gases expand, and therefore they have less mass per same volume, and then the balloon ends up floating. So yeah, I think there's a YouTube video. Somebody wanted to do station number 6 with a tanker truck. So they used a forklift or a crane to basically heat up a tanker truck. They sealed it up and then put it upside down into like a big tank of water, and it basically crumbled it. So lots of cool examples like this. All right. With that being said, are there any leftover questions? Something new, uncertain that you'd like to discuss? Something new or uncertain? We'll take a little lab quiz on this tomorrow, about 7 questions. Should be pretty easy. Questions? Something new, something uncertain. Going once, twice, sold. All right, let's go ahead and put that away.